Hello friends, welcome to Shiksharthi. In this video, we'll be solving questions from exercise 5.3 of arithmetic progressions. So let's start. Now, talking about question number 4. So now when I talk about question number 4, let us see what does question number 4 say. So it says how many terms of the arithmetic progression, and the progression is 9, 17, 25. So let us say 9 plus 17 plus 25 because we are taking an arithmetic progression. Now this adds up to a 636 and you have to find out the value of n. So how many such n terms you would have taken such that they add up to a 636. So we already know the formula. The formula is the sum for first n terms of an arithmetic series or a progression is given by n by 2 of 2a plus n minus 1 into d. Right? Now using this formula, we already have the sum with us, which is 636. This is equal to n by 2 of, what is the first term here? 9. So this becomes 18 plus n minus 1. What is the common difference here? 8. So can we put it like this now? So this is just like saying 1272 is equal to n times of 10. So let's, instead of saying 10, let's first put it as 8n plus 10. This is what we get. Solving this further, we will be able to say that this is nothing but 8n square plus 10n plus 1272 is equal to a 0. Further, we can say this is 4n square plus 5n plus 636, which gives us 0. So now this is a quadratic equation that has been formed thereafter. So what do we need to do? We just need to use the formula for quadratic equations, finding out the real roots. So how to find out the real roots here? So we already have the formula wherein we know that alpha is equal to minus b minus root delta upon 2a, and beta, let's say alpha is one of the roots and beta is another root, is equal to minus b plus root delta upon 2a. So we just need to substitute the values from here, which is just like saying, so this is a, so let's say this divided by 8 in both the cases. Minus b means minus 5 minus root of delta that we don't know, delta we need to calculate, minus 5 plus root delta. Now we need to calculate delta, and we know that delta is equal to b square minus 4ac. So when we do this, we realize that instead of this being a plus 1272, this is minus 1272. Okay, so b square, so let's say here, now b square is equal to a 25, and then you multiply 4 along with 636 again into 4. So how much is, so ultimately we say this is 16 into 636. How much is 16 into 636? So eventually, so you are adding how much? You are adding this. So eventually you will be able to say that this is nothing but no, I'm so sorry. So this eventually becomes how much? So if I'm adding a 25 to this, this becomes 10201. So how much, what is the square root? So I need to find out the square root of 10201 is what we need to find out. So I am rubbing this out because now we know what needs to come under the head of delta. So can I say that this is 101 whole square? So based on my practice, now I here refers to any one of us. Based on my practice, I'll be able to say that 101 whole square is nothing but saying like, find out the 100 square first, which is 1 followed by 4 zeros plus 101 plus 100, which is nothing but 10201. So the answer should be at 12, because from here I know that minus 106 is not a multiple of 8 and n needs to be a natural number. On the very sight of it, I can neglect this is because of the fact that here I am getting a minus sign and here I was getting a plus sign. So I should not even waste my time trying to calculate this, because the number of terms can never be a negative value. So the answer here is 12. Moving on to question number 5. Okay, question number 5 says the first term of an arithmetic progression is 5. Okay, so let's say the first term here is 5. The last term, so let's put it as A1. The last term here is 95. Okay. Oh, last term is 45. And the sum is 400. So you need to find out the number of terms and the common difference. The sum of these n terms is equal to a 400. Okay. And we need to find out the common difference and the number of terms. Okay, now what do we do? So one theory is, we know that the first term plus the last term is equal to the second term plus the second last term is equal to the third term plus the third last term from both the sides, but that may not make much of a difference here. The reason here is, let's see whether it makes any difference or not. So we know that sum of n terms can also be written as A1 plus AN, or I could have written it as T1, because generally I take it as T1, which is the first term, and Tn as the last term. So once you know the formula, then you can use any term as long as you are able to remember. Okay, now we already have this value as 400. We do not have the value of n, but we have the sum A1 plus AN, which comes out to be a 50. Okay, so what is the value of n from here? Can I say 16? Yes, I can. Now using the formula Tn is equal to T1 plus n minus 1 into D, we'll get the common difference from here. Do we know the nth term? Yes, which is a 45. Do we know the first term? Yes, which is a 5. Do we know the number of terms now? Yes, we know it. And 16 minus 1 is 15. So 15 into D. So from here we'll be able to say that 15D is equal to a 40. So which is just like saying D is equal to 8 by 3. So we'll check the value once again, because the moment you get the answer in terms of a fraction should raise some alarms. Not every time, but some of the times, or maybe every time you get an answer in terms of let's say a fraction, you should at least cross check the answer once. Okay, so we know the nth term, right? We found out the number of terms also. Was that done correctly? Yes, that was done correctly. Now Tn is 45, T1 is 5, 16 minus 1 is 15 into D. So 40 makes it equal to D. We cancel both the sides with a 5, and that is how we get the value of D as 8 by 3. Okay, moving on to question number 6. So talking about question number 6, it says the first and the last term of an arithmetic progression is given to you. So first term is given to you as 17 and the last term is given to you as 315. And what are they asking you to find out? They are asking you to find out if the common difference is given to you as 9, how many terms are there and what is their sum. So the common difference is given to you as 9. So they are asking you to find out the value of n, and the sum of first n terms is what they are asking you to find out. Okay. So from here, now we already know that there is a formula which says that Tn is equal to T1 plus n minus 1 into D. We already know this formula. So applying that formula here, I'll be able to say that 315 minus 17 divided by D, which is 9, is plus 1, gives me the value of n. So when I solve this, so this comes out to be 333 divided by 9. So how much is 333 divided by 9? 36? No, 37. And 37 plus 1 is equal to a 38. So the number of terms that we get from here is this. Now applying the formula, which is sum of n terms. So the sum of first n terms is equal to n by 2 of T1 plus Tn. So n by 2, what is the value of n here? 38 divided by 2 is 19, and then the first term is already given to you as 17 plus the last term, which is 350. So which is just like saying this is 19 into 367. Okay, how do we do this? How much is 19 into 7? 133. 19 into 6, 114. 19 into 3, 57. So can I say this is a 6973? Now check out whether I have multiplied this correctly or not. Now if I have multiplied it correctly, naturally the answer should come out to be a 6973. Now this is not the only way. What you could have done here was, you could have said that this is 20 minus 1. You multiply this number with 20 and then you subtract a 367 from here. In any case, you get the answer as 6973. Okay, let's move on to the next question. Now question number 7 talks about find the sum of first 22 terms of an arithmetic progression. First 22 terms. So here the number of terms are 22. First 22. Thereafter they are saying that the common difference is 7. Okay. And they are talking about the 22nd term as 149. And they are asking you to find out what? Find the sum of first 22 terms. Okay. Is the first term given here? No. If you are able to find out the first term, maybe the problem is solved. So the first term, now using the same formula as we have been using earlier. So can I say that now Tn is how much? 149 minus n minus 1. How much is n minus 1? 21 into d, which is 147, gives me the first term, and the first term comes out to be a 2. Now what is the sum for first 22 terms? Is n by 2 of t1 plus tn, which in this case becomes 22. So can I say this is nothing but 11 into 151? How much is 11 into 151? This should be the answer. Moving on to question number 8. Now question number 8 says, find the sum of first 51 terms of an arithmetic progression whose second term and the third term. So they have given you the second term and the third term as, now the second term here is, so they've given you the second term and the third terms as 14 and 18 respectively. Okay. And then they're asking you to find out the sum for first 51 terms. Okay. Now, what do we do here? Let's see. So, can I find out the first term? Yes, I can find out the first term because the common difference here is T3 minus T2, which is 4. So, the first term comes out to be 10. And we know that the second term is 14 and thereafter. So, this arithmetic series gets converted into 10, 14, 18. Now, this is arithmetic progression. And similarly, you have to find out the sum till the 51st term. So, you have to find out the sum for first 51 terms. So the sum for first 51 terms, we can calculate it as, this is 51 by 2, then twice of a, which is 10, plus n minus 1, which is 50, into d, which is 4, right? And this comes out to be 51 by 2 into 220, which is nothing but 51 into 110, which is just like saying 51 and 51, which makes it 561. 5610. Let's move on to question number 9. Okay, question number 9 says, if the sum for first 7 terms of an arithmetic progression is 49. So sum for first 7 terms is 49. Okay. Further it says, and that of 17 terms, first 17 terms is how much? Is 289. Okay. Find the sum for first n terms. This is what you need to find out. Okay, now we know this formula for first n terms, and the formula for first n terms is already written here, which is just like saying n by 2 of 2a plus n minus 1 into d. Right? Now if I find out the sum for another k terms, so this is the sum for first n terms. The sum for first k terms wherein k is greater than n. So you can find out that also from here, and you will say this is k by 2 of 2a plus k minus 1 into d. And then you can find out the sum for first n terms. Okay. Okay, now what do we do in this question? Let's see that. So can I work out the sum for first 7 terms? Yes, this is 7 by 2 of 2a plus n minus 1, which is 6 into d. Right? So from here you will be able to say that 2a plus 6d is equal to, now this was 49. So this comes out to be a 14, which is just like saying a plus 3d is equal to a 7. So let's say this is equation number 1. Now sum for first 17 terms is just like saying 17 by 2 times of 2a plus 17 minus 1, which is 16d. Now this can be further written as, so I can always cancel a 2 from here now, and I can say that a plus 8d. Now this is how much? How much is 17 square? Is it a 289? Yes. So a plus 8d comes out to be 17. Now this is just like saying you got this as the first term. This is the this is the fourth term of the series, and this is just like saying you've got the 9th term of the series. Now let's say if this is equation 2. From equation 2, if I subtract equation 1, what will I get? I will get 5d is equal to 10. So the value of d, the common difference, comes out to be a 2. And now you are supposed to find out the sum for first n terms. That also you can find it out, but in that case let me first find out the value of a, which I can substitute in either of the equations. So from here we get the value of a as 1. So the sum for first n terms is nothing but n by 2 times of 2a, which is 2, plus n minus 1 into d. And which eventually you can say, eventually is when you say it finally. So now when I see this is 2 plus 2n minus 2, which can be written as 2n only. So this is n square.